Greetings. Welcome to Nextwell's course on supervised and unsupervised learning. Let us start today's session by seeing a short video clipping. What do you see in this video? Roads, vehicles, stationary and moving, signboards, and I'm sure you all noticed the blue boxes around the cars. These are called bounding boxes. Are these boxes made by human? Well, to know all about it, stay tuned. Since we're talking about videos, I'd like to mention that YouTube Bounding Boxes is a large-scale video bounding box dataset. All of Google's videos have been manually annotated in bounding boxes. Today, Google boasts a 95% labeling accuracy with this bounding box video dataset. Before we get into today's topic, let us quickly recall what was done in a prior course. Overall, we focused on what is AIML, what is machine learning, what is the relationship between inputs and outcome. We were introduced to all of these whats with an example of a tea vending machine. We were also introduced to the 4 steps of an algorithm model. Now that you understand what is AIML, you might have an impression that these are advanced concepts which are to be carried out in data research labs by data scientists or by huge corporates with high budgets. Why are we talking about it at all? Hang in there and we will understand our plethora of opportunities down the lane. Our learning objectives for this session would include supervised and unsupervised learning, data science workflow, the human touch opportunities. Does it ring a bell? Yes, our tagline. Types of data and Nextwell's artificial intelligence capability matrix. By the end of this session, you will have a very good understanding on all of these topics. Most importantly, why are we learning all of these? Machine learning tasks can be broadly categorized into 2 major categories, viz. Supervised learning and unsupervised learning. First, let us look into supervised learning. When can supervised learning happen? Well, supervised learning can happen when we have data points with known outcome. For this, we would need to have a data set. Know the correct output for that particular data set, which in other words also means to know there is a clear relationship between the input and the output. Do you remember the example of the tea vending machine from a prior course? The inputs were quality of tea powder, milk, sugar, boiling temperature, duration of heating, and so on, while the output was the taste of the tea, which could be good, average, or bad. Well, now comparing it with the supervised learning definition, we have the data set, we have the correct output, and we also know its interrelation. So this example qualifies for a supervised learning scenario. We will look at another example in this session. This example involves deep learning as well. Deep learning consists of multiple hidden layers in an artificial neural network to model the way the human brain processes light and sound into vision and hearing. Okay, let us say we want to model to identify images of birds. How do we do that? This can be done by training the model. In order to train the model, we will add a label to each picture initially. I will label this picture as a bird. This is not a bird. This is a bird. This too. This is not a bird, and not a bird either. Once I feed these labeled images to the model will learn with the help of the numerous hidden layers of neural networks we just spoke about as to what is a bird and what is not a bird. Neural networks mimic the neurons in our brain and learn in a step-by-step fashion. It is just like teaching a little child. On day 1, the baby doesn't know anyone. But very soon, the baby can identify mother versus others. So this slide shows you a simple diagrammatic form on how a supervised learning model gets trained. Labeled data or data with outcome plus a fitted model together gives us our desired trained model. Now that we have a trained model, let us give it some input which is not labeled. Here we are giving it a picture of an animal. You might recall we gave a deer in the prior set as well, but that deer was a different one. The trained supervised model can now recognize that this is not a bird. Let us do another picture. To this trained model, we'll give it a totally new image which it has never seen before. There are high chances that it will predict it to be a bird or not a bird correctly. It is because the model has already learned from its previous data that we have given it, and this time it uses it wisely. It will first classify the picture with its shape, color, features, etc. and would confirm it as a bird and put it in the bird category. Thus, the model learns the specific details from training data and then applies the same knowledge to the new data or the test data or the new images which we give it. Please understand this important aspect here. The training happens under the supervision of a human like a teacher who already has knowledge of correct answers, and the model iteratively makes predictions on the training data and is corrected by the supervisor. Once our ever-learning model achieves the acceptable level of training performance, we could put the model into production. Back to our simple diagrammatic representation. What can we conclude with the supervised learning model? If data with outcome is given as input to a trained model, it processes and gives us predicted answers. The input data is an image which is not labeled, and we want the outcome to be predicted. There are various applications where this concept can be applied. Here are a few of them. They should only enable you to think further and look for more such applications in your daily life. We'll just have a look at one of the example and go deep into it. The rest you can figure it out. Let's look at spam detection. In recent times, unwanted commercial bulk emails, which is called spam, has become a huge problem. The spam email is responsible for over 77% of the whole global email traffic. Can you believe it? What a waste of bandwidth. Leading email providers such as Gmail, Yahoo Mail, etc. have employed combination of different machine learning techniques in its spam filters. Due to supervised learning, the model has the capacity to learn and identify spam mails and phishing messages by analyzing loads of such messages throughout the vast collection of computers. The machine learning model used by Google have now advanced to the point that it can detect and filter out spam and phishing emails with about 99.9% accuracy. Amazing, right? Similarly, AIML finds its applications in fields such as bioinformatics, information extraction, database marketing, information retrieval, speech recognition, handwriting recognition, vehicle driver assistance, pattern recognition, so on and so forth. And that brings us to the definition of supervised learning. I'm just going to read this out for you, okay? In supervised learning, you train the machine using data which is well labeled. It means some data is already tagged with the correct answer. It can be compared to learning which takes place in the presence of a supervisor or a teacher. With this, we conclude supervised learning. In our next few slides, we will be discussing about unsupervised learning. Unsupervised learning can happen when we have data points with unknown outcome. This method looks for similar features and clubs it together. Since it is an unknown data set with unknown output, unsupervised learning method is best used for clustering. Unsupervised learning takes place in real time. Unlabeled data is easier to get as it needs no manual labeling effort. This is fed into the model and the outcome is clustered with all similar data points together. So, here there is no direct relationship between a single data input and corresponding single data output, but there is a similarity between all of the group data. We will now look at similar animal-bird example which we considered while doing our supervised learning. This example involves deep learning as well. Do you remember what deep learning is? Just a recap. Deep learning consists of multiple hidden layers in an artificial neural network to model the way human brain processes light and sound into vision and hearing. Okay, here we have the same set of images used in a supervised learning example. However, in this case, the images are not labeled as bird or not a bird. This full set of unlabeled images is fed to the model together. The model will process these images. Now you can see what our model has given us as an outcome. The 7 input unlabeled images are clustered into 3 different groups. One group that crawls, one that flies, and one that walks. I would like you to understand this important aspect. Here the work happens under no human supervisor, nor is there any knowledge of correct answers. The model iteratively makes predictions on the input data and is further used by the user. We are back with a diagrammatic representation. Okay, this is on unsupervised learning model. Unlabeled data plus a model predicts to give us predicted similar clusters. Here data is an image which is not labeled and model will predict into which cluster it must be put in. It is just like a little child who learns by seeing what happens in his or her surroundings. On day 1, the baby doesn't know anyone, but very soon the baby can identify family versus others. There are various applications where this concept can be applied. Here are a few of them. This should enable you to think further and look for more such applications in your daily life. Clustering automatically splits the data set into groups based on their similarities. Anomaly detection can discover unusual data points in your data set, so it is useful for finding fraudulent transactions. Association mining identifies sets of items which are often occurring together in your data sets. Web search engine. One of the reasons why web search engines like Google, Bing and all work so well is because the system has learned how to rank the pages through a complex learning algorithm. And that brings us to the definition of unsupervised learning. Unsupervised learning is a machine learning technique where you do not need to supervise the model. Instead, you need to allow the model to work on its own, to discover information and cluster it accordingly. It mainly deals with unlabeled data. With this, we conclude unsupervised learning. Now that you understand both supervised and unsupervised learning, please tell aloud, what is the first main difference or the main difference? Did you say that there is a need to manually label each picture in the supervised learning, whereas in unsupervised learning, the full set of images can be directly fed in with no manual labels attached? Yes, then that's correct. So here we go. This picture captures exactly the same. We have one set of birds and not a bird which is labeled manually and the other set which is not labeled. And these will be fed as is to the system. In reality, most of the work involved falls under the supervised learning kind of work area, which is very good news for us as we are in the space of doing such manual work. I would like to pause here for yet another understanding check. We started today's session by seeing a short video clipping. There were several bounding boxes in it. I had asked you an open question then. If those boxes were made by human, if yes, why? I'm sure you are now in a comfortable position to confidently answer it. Yes, please say that along with me. They are manually made boxes to be fed as labeled input to a supervised learning model, and thereby the model can do its learning. Recap. I would like you to recall the 4 steps of AIML we earlier saw in the past session. Yes, say that aloud with me. 1. Prepare the data or pre-processing of data. 2. Machine plus an algorithm which gives brain to the machine. 3. The brain machine to undergo training and testing, in other words learning along with known input and output data sets to make an intelligent machine. Finally, deployment into production where new input data is processed to predict outcome by the intelligent machine. Now I am sure you will agree with me that human touch is needed in supervised learning to prepare the training data for the algorithm. The first 3 steps cover the entire development of the supervised learning model. Here we are back to our simple diagrammatic representation. This highlights the work that we, as in Next 12th, can do as part of this development cycle. How can we be involved here? The raw data and the data labeling for the model development is one place we can work on. This label data is used to train the model. The first human touch opportunity, this is called model training. After the model gets trained in development environment, it is moved to the staging environment, where it needs to be tested with unlabeled data. Since the data is unlabeled, we will again need human touch to validate the model. This is one more place we can work on. This model will show the output as predicted. However, the human will have to validate and confirm if the prediction is correct or wrong. The second human touch opportunity is called model validation. After the model has been developed and later tested in the staging environment, it is finally moved into the production environment. Here the model will work on production data in a live situation. However, there is still a minute risk that the model might not work for some unknown cases in live production. In such a situation, a human touch is needed to manually validate and make appropriate correction to the output. Yet another place we can work on, the third human touch opportunity. This is called exception handling. Now let us look at all that we did in the last 5 minutes. The 3 opportunities for human touch where we can do work are 1. Model training, 2. Model validation, 3. Exception handling. Now that we know the kind of work we at Next12 can do, let us understand the types of data involved to do this sort of work. First, we will look into computer vision kind of data. This will involve images or videos. The typical human work for images could be labeling, putting bounding boxes, and such. We saw a similar example while defining supervised learning with images of bird and not a bird. For videos, the human work could be either tagging or object tracking, which can be done by putting bounding boxes for a particular object of interest all along the video, and so on. More details will be shared with you in subsequent trainings on how to do this kind of work. Let us look into natural language processing kind of data. In short, we will refer to it as NLP moving forward. This will involve sentences which are in text or audio format. The work that we can do for text could be parts of speech tagging like subject, verb, object, or like intent of the entire sentence, and so on. In this sentence, Germany is the subject, one is the verb, World Cup is the object. For audio, the work we can do could be to identify words and tag them in the audio or summarize the intent of the entire audio. Last but not the least, semi-structured and structured type of data. The tabular structure you see here is a classic example of structured data. This is data from our very own tea vending machine example. So everything input output is defined like tea leaf quality, milk quality, sugar, etc. and the tea tastes. On the other hand, let us assume we want to collect data from the internet on a specific requirement. Here we'll have to look at multiple sources and pull the information of interest. This could be classified as a semi-structured type of data. This is a representation of Next12's AI capability matrix. This shows us the full range of Next12's human touch opportunities at one place. On the top horizontal, we have the 3 types of data we just spoke about. And on the vertical, we have the 3 types of work we can do at Next12. Very clearly, we are capable to do all of the combinations. A quick summary on all that we did in this session. Overall, this session talks about why we at Next12 need to know about AIML. Keeping this spirit in mind, we covered topics on supervised and unsupervised learning along with the bird, not a bird example. Now let's recall Next12's tagline. Human touch to digital processes. Human touch are the key words here. We looked at the data science workflow where we understood the 3 human touch opportunities of interest to Next12 such as model training, model validation, and exception handling. Then the 3 types of data which includes computer vision, NLP, semi-structured and structured data. Last but not the least, the 3x3 AI Capability Matrix. With this, we come to the end of this session. I hope you enjoyed learning why AIML just as much as I enjoyed in the making of the same. Congratulations! Stay tuned. Further session will cover how to do AIML work. Now it's time for a short quiz to test your understanding. Best wishes. Thank you.